All right, 8th graders, today is a new Monday, starting a new week. So, we are going to look at solutions to systems of equations. So, the definition of a system of equations is where we're going to start. So a system of equations is a group of equations with the same variables. Remember, those are letters. So here's another definition. The solution to a system of equations the solution to a system equation is the point x, y that makes all of the equations true. So in the interest of time, we are going to use these graphing charts together. So if we were to write the equation for both of these lines in the slope-intercept form, hopefully after lots of review a week or so ago, you remember that slope-intercept form, y equals the slope times x plus the y-intercept. So let's look at the first equation. We'll call this line A. So we want the y-intercept. It looks like 0. So our b is going to be plus 0. So we're not even going to worry about that. But our slope, as you can see, if we picked 2 points on our line, it looks like it's going down 1 over 1. So negative 1 over 1. So negative, right, is negative 1. So we could write y equals negative x, and plus 0 would just be y equals negative x. Then our second equation for this line B, we'll call it, our y-intercept is right here at negative 2. And from here, it looks like we're going up 1 over 1, up 1 over 1. So our slope here is 1. So we have y equals 1x, which we'll just write as x, minus that 2. All right. Now it wants us to describe the location of the point negative 2, 2. So negative 2, 2 would be right here. So this point is on line A. I just so happened to pick that as I was making my slope. Test the point negative 2, 2 in both equations. Okay, so if I put in on the first equation, I would have 2 equals the opposite of negative 2. So 2 does equal 2. So it does make the first equation true. But if I test it in the second, I have 2 equals negative 2 minus 2. See how I'm putting these point values, x and y, into equation, first equation and the second equation? So 2 equals negative 4. That doesn't work. So it only worked on the line that it was on. Okay? So the location of the point -2, 2 was only on line A. Now it wants us to describe the location of the point -1, -3. So -1, -3. So that one is right here. And this point is on line B, right? Or on the second equation. So if we were testing this point in both equations, if we test it in point A, remember this is the y value, so we say -3 equals the opposite of -1. See how I'm putting this in for x, but we had to take into account that negative there. So -3 equals 1. That's not true. So it doesn't make the first equation true. The second equation, we have -3 equals -1 minus 2. So -3 equals -3. So it does work for our line B. And we should expect that because that point was on line B. And we expected this because it was on line A. Now let's describe the point 1, -1. So over 1, down 1. Oh, look. So they're on both lines. So that is our point of intersection, or point where lines intersect. That's where they touch each other, right? That's where they meet. So if we test the point in both equations, we should find that it should work for both, right? So let's test it for the first one. We have -1 equals the opposite of +1, right? Because that's our x value. So this is saying -1 equals -1, which is true. For the second equation, line B that we called it, we would say -1 equals 1 minus 2, which we know is -1. So -1 equals -1, and it works for both. Which point worked for both equations? 1, -1. Why do you think it worked in both? What do you think, guys? It was on both lines, right? Okay, now let's look at some more. So, in a rule, the solution to a system of graphs is, remember, the point that makes the equations true is, look right here, the point x, y that make, on a graph though. So we could still call it the point x, y, but we'll say where the lines intersect. That's fair enough. So write the equations for both lines of the graph in slope-intercept form. So again, if we look at this first one as A, let's say y equals, what is the slope? Well, first our y-intercept looks like it's right about 3. And maybe there's a point here also, so it's going down 1 over 2, so -1 over 2 x, and then we said plus 3 was our y-intercept. Our second equation for the second line here, our y-intercept looks like it's here, and it instead it's going up 1 over 2, so it's positive 1/2 x. So y equals 1/2 x, and our y-intercept was 1 here. What are the coordinates of the solution to the system? Remember, the solution is where they meet. So what are the coordinates of this point right here? So our x value is at 2. Our y value is also at 2. Test your solution in both equations. We can do that, right? So if I put 2 in here, I would have 2 equals negative 1/2 times 2 plus 3. So this is 2 equals negative 1 plus 3. 2 does equal 2, so it works in point A. Or 2 equals 1/2 times 2 plus 1. So 2 equals 1 plus 1. 2 does equal 2. Alright, see what you're going to do to check your solutions. See how our solution is the point where they intersect. You are welcome to go on to today's Desmos activity. Or you're welcome to stay. I'm going to do one more example. So when we're writing the equations, remember we need to find the y-intercept, which here is 2, and the slope. So it looks like this one is going down 1 over 1, so negative 1 over 1, which is just negative 1. Or we're going to write it as y equals negative x plus our y-intercept, which was 2. And then our second equation for this line, let's look at our y-intercept there, and it looks like it's going up 2 over 1. So up 2 over 1, rise over run, our slope is 2. So y equals 2x minus 1 here. So what are the coordinates of the solution? So we find where they meet. Our x value is 1. Our y value is also 1. Now they won't always be the same, right? Like these two examples were. So if we were testing our solution, we'd say 1 equals negative 1 plus 2. So 1 equals 1. So it works in the first one. And 1 equals 2 times 1 minus 1. So that's just 2 minus 1 is 1, right? 1 equals 1. So it works in the second. So as you can see, we're going to find the point of intersection to find the solution, and then we're going to test that solution. All right, I hope you guys have a fantastic day.